Hi everyone, welcome back to the channel. In this lesson, we are going to learn one of the most powerful repair tools in CATIA Part Design, Remove Face. This tool is extremely useful when you don't have access to the design history and need to edit imported or complex models quickly. Let's get started.
I got this magic in my fingertips, designing dreams with every click. Shapes and wonders coming to life. With CATIA, I cut through strife. In my mind, the future's clear. No more doubts, no more fear. Crafting visions in 3D. CATIA's the key, don't you see? I can reach the sky so high. Build my dreams, no need to try. With every tool I sculpt my fate. CATIA helps me innovate. Every line precise and true.
Hello everyone. Today we want to talk about the Remove Face tool. Assume that we have a shape like this. Now I want to remove the lower part of the cylinder. For this, I can double click on the cylinder path command in the specification tree. In the path definition window, I can change the sketch length. But sometimes we do not have access to the part specification tree. I will explain this situation in a separate section. For now, assume that we do not have access to the design tree. In this case, the software provides a special tool for us. Its main uses are fast editing of imported models, removing extra protrusions or cavities, and simplifying the model without changing the history. The name of this tool is Remove Face. This tool is used to remove one or more faces from a part. Note that this tool only accepts face selection, but the result is applied to the body, not to an edge or a feature. I click on this tool to activate it. Its definition window opens. This window has two sections. In the first section, we have three options. The first option is called Faces to Remove. There is a box in front of it. This box is now blue and ready for selection. Here we must tell the software which faces we want to remove. I click on the bottom face and the side face of the cylinder. These two faces become pink. The software detects that the cylindrical side face is cut by a planar face. For this reason, it automatically limits the removal up to that face. Now I must define the limiting faces in the Faces to Keep option. We use this option to define the limiting faces for the software. I click inside the box in front of this option to make it blue. Now I click on the bottom planar face. This face becomes blue. The name of this face is shown in the box. This tells the software how far the cylinder removal should go. If I click OK at this stage, the cylinder is removed up to the selected face. I press Ctrl+Z to return to the initial state. Now I create a plane. This plane is 20 mm away from the bottom face of the cylinder. I activate the Remove Face command again. I click on the bottom face and the side face of the cylinder to make them pink. Now I click in the box in front of Faces to Keep to make it blue. I click on the plane that I created. I get an error message. The error says that I must select a face that belongs to the body. I click Cancel. The result is that in this tool, we must use faces that belong to the body itself to define the removal limit. I activate the command again. I want to remove the bottom and the top of the cylinder at the same time. In the Faces to Remove box, I first click on the top face, and then on the bottom face of the cylinder. Note that in this example, I don't click on the side face of the cylinder. Now I click in the Faces to Keep box. I click on the two faces of the cube. The software understands how far the cylinder should be removed. There was no need to select the cylindrical side face. I click OK. You can see that the top and bottom of the cylinder are removed. Now assume that we have a cube. One edge has a fillet and one edge has a chamfer. I activate the Remove Face tool. In the Faces to Remove box, I click on the fillet. In this example, there is no need to use the Faces to Keep option. I click OK. You can see that the fillet is removed. I do the same thing with the chamfer. Now assume that we have a cube with fillets on 3 connected edges. I activate the Remove Face tool. In the Faces to Remove section, I click on the corner fillet. I do not use the Faces to Keep option. I click OK. You can see the resulting shape. I go back one step. I activate the Remove Face tool again. In the Faces to Remove option, I select one fillet on one edge. I click OK. I get an error message. The software says that after removing this face, the body cannot be closed because volume continuity is lost. I click No. The error closes and I return to the Remove Face definition window. Now I also click on the corner fillet. I click OK. You can see the shape. Now assume we have a cube with a cubic pocket inside it. We want to close and remove this pocket. First, I activate the Remove Face tool. Then I select all the faces of the cubic pocket in Faces to Remove. If I click OK, you can see that the pocket is removed. Or here, I select only the bottom face of the pocket as the face to remove. In Faces to Keep option, I select the top face of the cube. In this case, the pocket is also removed. Now assume that we have a shape like this and we want to remove the window. First, I activate the tool. In Faces to Remove, I select the side faces of the window. In Faces to Keep, I select the two side faces of the cube around the window. I click OK. You can see that the window is removed. Now look at the second section of the Remove Face definition window. There are two options in this section. The first option is called Limiting Element. This option is usually a reference face that defines the removal limit. This means the removal continues until it reaches the limiting element. If this option is empty, the entire selected face is removed. The second option is called Face to Limit. This option defines which reference face is used to stop or limit the removal. Now consider this shape. I want to cut one side of the cylinder to a specific limit. First, I select the side face of the cylinder on one side. I can also select the side faces on both sides. Just remember not to select the circular face of the cylinder. I go to the second section. First, in the limiting element box, I select the YZ plane. When I select this plane, an orange arrow appears on the cylinder face. Now you can see a name in the Face to Limit box. The software has selected a reference face. I click OK in this state. The software cuts the inside of the cylinder up to the YZ plane. Now consider another shape. A cube with two cylindrical holes inside it. The upper cylinder has a larger diameter and the lower cylinder has a smaller diameter. There is also a groove between them. I want to remove the upper cylinder. First, I activate the command. Then in Faces to Remove, I click on the side face of the larger cylinder. Now I click in the limiting element box to make it blue. I click on the bottom face of the smaller cylinder. Now in the Face to Limit box, I click on the middle edge between the two cylinders. I click OK. You can see that the larger cylinder is removed. Another shape. A cube with a cubic pocket and a straight groove. I want to remove the groove. After activating the command, in Faces to Remove option, I select the faces inside the groove. In Limiting Element, I click on the front face between the two pockets. In Face to Limit, I click on the side face of the lower pocket. I click OK. You can see that the groove is filled. Now let's make the topic a little more complex. This time I want to remove a circular groove. First I activate the command. I select all groove faces in Faces to Remove. In Limiting Element, I click on the front face between the two pockets. In Faces to Limit, I click on the side face of the lower pocket. Before confirming, pay attention to this point. At the bottom of this section, you can see a large box that shows the list of selected faces. You can have several faces in the Face to Limit. All these faces are shown in this list. Now I click OK. You can see the result. An important point is that Remove Face always tries to rebuild the body as a closed and valid solid. If this is not possible, the command stops with an error. Finally, I must say that this tool is very useful when you import models from other software. I will also show you 3 examples. Look at them carefully. In each one, some parts of the original shape are removed. This tool is one of the important tools in CATIA. Sometimes using it can look confusing and complex, especially the 2 options in the second section. With practice, your skill in using this tool will improve step by step. Please watch the lesson twice. In the second time, practice together with me. Good luck. Goodbye until the next lesson.
Let's build a